Welcome, class. Today we'll discuss spectroscopy and the electromagnetic spectrum. Before we can begin to talk about spectroscopy, we must first review the electromagnetic spectrum. The electromagnetic spectrum is made up of 7 segments: radio waves, microwaves, infrared waves, visible light, ultraviolet X-rays, and gamma rays. Usual ocean waves, electromagnetic waves travel in a defined direction, while the speed of ocean waves can vary. However, the speed of electromagnetic waves, commonly referred to as the speed of light, is essentially constant, approximately 300 million meters per second. That's it. Although electromagnetic waves travel at the speed of light in a vacuum, they do so at a wide range of frequencies, wavelengths, and photon energies. Now let's move on to spectroscopy. All the 2 types of radiation on the electromagnetic spectrum are used for some type of spectroscopy. Those 2 are gamma rays and microwaves. When radiation is applied to a sample of an element or molecule, the radiation might be absorbed by the element or molecule or just bounce off the particles. The wavelength at which energy is absorbed gives us information about the particle. Spectroscopy is the study of the interaction of radiant energy and matter. Different types of radiation do different things to the molecule and tell us different information about the molecule. X-rays remove more electrons and tells us how tightly the electrons are held by the nucleus. This form of spectroscopy is known as electron spectroscopy. Ultraviolet and invisible light excites valence electrons and tells us the identity of a molecule or element. This form of spectroscopy is known as visible spectroscopy. Infrared changes the vibrations in the bonds and tells us the types of bonds and functional groups within a molecule. This form of spectroscopy is known as vibrational spectroscopy. Microwaves change the rotations of the atoms in the bonds and tell us the locations of hydrogen atoms within a molecule. This form of spectroscopy is known as microwave spectroscopy. Let's review an ODAP exam question. For part of section 1, we will count the number of electrons released to figure out the subshell. The first peak is 1 st. The second peak is 2 st. The third peak is 12 st. The fourth peak is 3 st. The fifth peak is 3 st. And the sixth peak is 4 st. Therefore, the electron configuration for this element is 1 st, 2 st, 12 st, 3 st, 3 st, 4 st. For section 2, we will use a periodic table to find what element has that electron configuration. From looking at the table, we can see that this element is Gaussian.